I am not going to do any introductions. I am going to let you watch this. Just watch this. This is what we're doing. Now we should be able to pay or buy NFTs using different cryptocurrencies. How much did we charge the contract using USDT? And we can check. Let's see. USDT is number one. So we're charging 150 USDT per NFT minted. So if we select 2, it's going to be 300. You know what? Let's select 3. So we change the value. We know it's different now. So it's going to be 450 USDT. Okay. And we're going to use USDT. That's PID1. And we're going to mint to my wallet, which ends in 55. Let's go ahead and transact. And let's wait for that. 450. So we should lower ourselves to 9,560 and 50. 550. 9,550. Wait. Awesome. Awesome. There you go. We bought using into the reward tokens, our staking tokens. Now we bought NFTs from the same collection using USDT. Now we are going to buy using Matic. And the only thing I have to do now is change this PID to be 2. That's Matic. And we're going to mint 3. Let's mint 3. Go ahead. Let's give it a shot. That's our last currency that we bought. And there you go. Wait. Awesome. 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 Let's make it happen. This is an ERC-721 NFT collection smart contract in which you can add multiple cryptocurrencies to be accepted as payment to mint NFTs. Not only that, but you also can update the price on the collection. So let's say you started selling the collection at 200 USDT. You can go ahead and lower it. Anytime you want, you can go ahead and lower that price to 100. Not only that, we want to accept Matic. No problem. Go to the smart contract, add Matic onto the token list, set the price in Matic, push it out. Your users can buy using Matic. You want to accept Ethereum, add Ethereum to the smart contract. Your users can buy in Ethereum. You want to lower the price on Ethereum? Go for it. You can update the smart contract without redeploying or anything. You can do this on the fly after the smart contract has been deployed. But for that, I gotta show you how this beautiful piece of art works. Let's go. All right, let's bring this beauty to life, because let me tell you, this is a work of art, okay? So what I ended up doing, right? I got the collection smart contract, and let me show you, just make sure that I want to make sure that you are all familiar with this. So we got our NFT staking collection smart contract. That is the ERC-721 NFT collection contract, right? So I went all the way to the bottom because those are all my interfaces. I just added those interfaces on the contract, but in reality, I could do the same by just importing. Okay, so the only thing I'm gonna copy, and by the way, I'm gonna provide the finished contract in the link of this video, so you should find it right now. So let me show you what we're gonna do. What we're gonna do, we're gonna copy all this, and this is what we are gonna be working with. So we're gonna copy all this, right? And then we're gonna go back onto code, and we are going to paste it in, okay? So very important. We know that the NFT 721 collection smart contract, it's ERC-721 enumerable, and we also know that it's ownable. So we know that we have both contracts imported because we need to use those interfaces to call the functions that we have here scripted or coded, okay? Now, I want to allow this NFT ERC-720 collection smart contract to be purchased or to be minted using other tokens besides the native token, okay? So for that, in order for me to do that, to accept any other ERC-20, including our own staking reward token, when I mean any ERC-20, I'm telling you any ERC-20, okay? What I have to do, I have to invoke the ERC-20 interface because I need to start interacting with that particular contract. So for that, I need to have an ERC-20 interface. So then I can start talking to that particular contract type, okay? So after we are done with that, you know what I want to do? I want to go ahead and clean this. So I had a bigger supply. I'm just going to put 1,000, but you get the idea. You can put any NFT supply here, or the maximum amount of NFTs in the collection. This is where you modify that. Another thing, what I'm going to do now, I don't need cost. Why? Because every time that I add a cryptocurrency to the smart contract to be accepted, I am going to apply a different cost. So I don't need that. Okay, so I remove that. Done. Okay, now here's the fun part. Okay, we have to do the following. We need to get the function that will call the ERC-20 token smart contract and tell, hey, I got a user that wants to buy an NFT. So this smart contract is going to talk to that smart contract, to the ERC-20 token, and say, hey, allow me to transfer that cryptocurrency because I need approval. So you need to tell the ERC-20 smart contract, hey, approve this particular user from spending those tokens to buy the NFT. Okay. So with that, I gotta go and show you the information that we have to tell. Okay, now I have to map the token that we need to use to pay for the NFTs inside the function. Okay, so I am going to show you right now what I'm talking about. The first thing I'm going to do, I am going to create a var inside the mint function that will talk to the interface, the ERC-20 interface, okay? Then I am going to call the variable that will store the contract address, and this is the ERC-20 token smart contract address, okay? Pay token. I'm just gonna make a name up, okay? Now, not only that, but I also have to provide the cost. So every time that I mint a token, I have to provide the cost. Okay, cost, first of all, I got to declare it, 256, and we're going to call this cost. Now I have to say now. Okay, so I got both things. What will happen? This is, imagine if I decided not to create the smart contract to allow multiple cryptocurrencies. The only thing then that I need to call is this, and tell in the mint function transfer from. This is the particular smart contract collection, which then we'll talk here. Okay, I'm going to show you that. So what I'm going to do now, I'm going to show you the command that will allow me to send a request to the ERC-20 token smart contract. The token that I'm going to accept as payment to the ERC-20 interface. And how do I do that? This is where I actually do the safe mint function, but before that, I have to do the action, which starts with the token variable, pay token, okay? And then I'm gonna call the function inside the ERC-20 interface smart contract, which is transfer from, okay? So we got that. Now, what I'm gonna do, MSG sender, obviously it's me, but then send the request from the ERC-721 token smart contract and inform the cost to the ERC-20 interface. What's happening in a nutshell? I'm gonna draw this real quick and I want to show you what is happening, because we need to know what's going on, right? So we got the NFT collection, ERC-721, okay, you got that, so we got, this is the smart contract. Okay, so we got that NFT collection, ERC-721 smart contract. We got another one. This will be the token that we are going to use to pay, the ERC-20 token smart contract. Okay, right? And then we got our wallet right here, wallet. Okay, so this is a particular user trying to request that mint. I'm gonna do here, I'm gonna change this color so it looks better. in the wallet. I don't know. I'm just going to make something. There you go. Awesome. So the first thing that happens, right? The first thing that happens is when I hit that mint button, the wallet, you know, myself, I am actually telling the NFT collection smart contract, I am going to this particular interface and I am calling this function. And I am saying 2 means my wallet address. My wallet address is actually 2. And I am also providing the cost. So when I hit that smart contract, I am telling how many NFTs do I want. And this is where you remember on a couple of videos and the Web3 dApp where we select how many tokens do we want to mint. This is what we're sending the mint function. Hey, this is my address. This is my mint amount. This right here is message.sender. It's the wallet, okay? Message.sender, it's sending the request to the NFT collection smart contract. Then what I'm going to say is the NFT collection smart contract is going to trigger this particular action, okay? It's going to say, hey, transfer from, so it's gonna call this ERC-20 token transfer from function. How it will call it? Using the ERC-20 interface. That's how we talk to that smart contract. We say ERC-20 interface, transfer from, boom, land on the ERC-20 token smart contract. This smart contract is telling this smart contract, hey, by the way, I have message.sender, this user right here. I got message.sender telling, hey, I need you to transfer from the smart contract, which he or she is holding on the wallet, a particular amount of tokens to the collection, so then I can in exchange transfer the NFT. This is literally in a nutshell what's happening, and we're using that ERC-20 interface. Why is it so important and why we need to configure that? It's because under the ERC-20 interface, we attach the token address, the ERC-20 token address, okay? So this is how the NFT collection can send that message, because under the ERC-20 interface variable, the pay token, let's go back, under the pay token, this is where we store that ERC-20 token smart contract, okay? So what I'm gonna do, I'm gonna say pay token dot transfer from message.sender, that is my wallet who's requesting that mint function, right? And we are going to send that request on behalf of the user using the NFT collection smart contract, okay? So I am basically acting as a middleman for this particular wallet. I'm telling, hey, send me, you know, I'm requesting you. And then this wallet should have authorized to send the funds to get the NFT minted, okay? So let's go back. Just want to give you the logical aspect of this particular call, okay? So now, after that is done, it goes ahead, proceeds to do the mint, and it retrieves that NFT from the collection and sends that to my wallet, and then it calls, you know, supply, then equals I, so then it increments the supply, so it knows that it took one NFT from the entire maximum supply. That's how we do it, okay? You are following me right now. You know, everything is good so far, okay? Good, let's continue, okay? By doing that, I can actually go and tell the smart contract, hey, by the way, now I know that I have a different token that I'm going to be using, okay? So I need to tell the smart contract, hey, by the way, I'm gonna be using a different token for this transaction. And this is how we do it. We set the ERC-20 and we call the pay token inside here. But then I need to call this, and we're not going to do it because I am going to give you the opportunity to select whichever token you want at the end. So we don't need to call it manually. But if you were not doing what we are going to do, then you, on the constructor, you have to tell, hey, this is the address. And then when you deploy the smart contract, it's going to ask you what token address we want to use, right? But you're going to see this, don't worry, okay? Not only that, This is what we need to do now. We also, because we are also receiving the ERC-721, I am going to make another slide. Now, because we are no longer receiving the default token, we are receiving a different token in the ERC-721 smart contract. This is the NFT smart contract. We are also receiving a different token. And by the way, do you know that this smart contract will hold your funds? So every time that someone buys an NFT, the tokens that were used to buy the NFTs, the cryptocurrency will be stored in the smart contract, okay? So we need to be able, after the tokens were transferred from the wallet, from the user wallet, so from that particular user who just got the NFT, from that wallet, we are going to get tokens or payout tokens delivered. We are going to get tokens delivered. That's our payout. This particular smart contract, it's going to store that token, that money, that income that you got from the sale. But we also need to make sure that we can withdraw that from our smart contract. So for that, I need to also create another function. This function will be called withdraw. And we do have already one that is set by default. If we don't use a particular cryptocurrency, we just use the default ERC-20 token on the blockchain, in this case ethereum or Matic, whichever the blockchain you're using, right? But now we're doing a little bit more than that. Okay, now we need to also call the interface. Remember, every time that we need to interact with that particular token that we are going to use as a payout, we need to call that interface, right? But now we are going to change this particular function. We are going to say, check this out. We are going to, by the way, call the same way. I'm going to use the token address. Then I am going to call the function in the ERC-20 interface from message.sender. And we are saying pay token balance of. Okay, why we're doing this? Address this. I'm going to explain this to you right now. Let's say user number one bought one NFT. He or she paid 10 tokens or whichever ERC-20 currency you selected to use. And let's say our entity rewards. We're selling the NFTs for 30 tokens, right? And we want to use entity reward ERC-20 token into the contract. We need to be able to withdraw those funds from the ERC-721 contract. Every time that someone mints, those funds will be stored on this particular contract. We need to take them out, okay? In order for me to do that, I have to call from the ERC-20 interface, I have to call the transfer function, okay? What am I going to tell that function? I am going to tell that function message.sender my wallet, right? Pay token balance of address this, okay? Pay token, that's the address of the token that we are accepting as payment. Balance of address this. What is this? The ERC-721. So in a nutshell, I am going to do this. I'm going to show you what's going on. Let me grab here. I am going to say this particular option that we're seeing right now, it's from this ERC-721. I am requesting how much do I have in the smart contract holding from all my sales. This is basically that. It's literally telling, hey, check how much balance, how many tokens do I have from the N2D rewards. So let's say we're accepting the N2 the rewards ERC-20 staking tokens. And this is the smart contract. So what I'm doing is I am telling this particular smart contract, hey, go ahead, allow me to transfer this to a particular wallet, okay? And the only wallet that is going to be allowed to do this particular call, it's going to be the only owner. What does that mean? That is whoever minted this smart contract. Whoever deployed this collection, it's only owner. He is or she is the only one that can trigger this particular call, because obviously if not, anyone will steal the funds. So we are basically telling, hey, I have a balance of your tokens in the particular smart contract, I want to go ahead and withdraw those funds into my owner wallet. Okay, because I have that stored in the smart contract, but I am the only owner of that 721 collection smart contract. Give me the money and transfer that to the message.sender. Okay, hey, I want to accept multiple cryptocurrencies. So let's go ahead and build this. We're going to call the struct, and the struct is basically, it's kind of it's an array of data. Like we have an array of information that we're going to store in this particular one big object, and we're going to use that object to be called multiple times. Okay, so let's go ahead and open that struct. And then the first thing that I'm going to do, what is going to be asked? Remember that we manually had in the smart contract to allow a different token to be used. We're just going to use the same thing inside the struct, but I do need that here, but I'm going to tell you why in a bit. Okay, so let me go ahead. I'm going to call this to be the token info, because I am storing all the information that I need from a token perspective to be called later on. We still need to call that ERC-20 interface, and we're going to call this pay token. Okay, that's how we do it. And also I need to be able to store every unique value of each token. And I mean the value, I mean the cost. How much do we want to charge if a user decides to pay us in a particular token? Okay, so we are just going to call 256 and we're going to say cost, and this will be the cost value. Okay, so we're calling this cost value, and I'm going to show you in a bit why we want to do it that way. Okay, and this is a name that I selected. You can select anything. Okay, next thing. Now we need to map this to a public array. So we need to use that information. I am going to grab the entire struct, and we want to be able to call all the information inside from a single variable, okay? From a single object. So for that, I need to call token info, and then I'm gonna open and close for the array, because I'm telling Solidity, hey, this is an array, it has multiple options inside. Okay, this is how we do it. And then we say public, because we should be able to read and write to it allowed crypto. I'm just going to call this way. This will be the information that I'm going to tell the smart contract every time that I want to add a different token to be used for payout. Okay, you're going to love this. Next thing that I'm going to do, I am going to do the following. Tell on the constructor, I am going to create a new function, and let's call this add currency. Okay, so the currency that we are going to use to pay for this will be from the ERC-20 interface, and we're going to do an underscore pay token, because we are going to ask this every time the contract deployer wants to add a different token for sell to sell the NFTs, right? So we want to add that, because I need to ask, hey, what's the contract address of that token that you want to accept as payment? Okay, so next what we're gonna do, we're in T256, and we're gonna say cost value, because we are also calling the UINT 256 value, and this is the placeholder, or this is the object that is going to store the cost of a particular NFT in a particular token that we are going to allow to use in the transaction. Okay, now I need to create another thing. I gotta make sure that only the owner, it's a public function, but only the owner can call this. And who's the owner? The owner of the NFT collection. Okay, and what I'm going to do, this is where that public array allow crypto will be used to create the pools. This is where we create that pool in which we store the contract address of the ERC-20 token, and we store the cost. How much are you going to charge on a particular token? So let's go ahead and do that. Let me call allowed crypto dot push, because every time someone calls this function, we are going to push that and create that pool. basically the PID. So every time that we add this function, it attaches the function to a particular index. That's the term that I want to use. A particular index will be attached to every function that we call. And we start with 0. So 0 is the first index that we create. Okay. And now what we are going to push? We are going to push token info, the struct. This is what we're pushing, and we are going to ask for those two items. Token info, we're going to open, and we are going to open the bracket here, and we are going to call pay token. And then what am I calling this? What I should be expecting as a value? The input from the contract owner every time that he or she wants to add a different crypto to be used for payout. And then the cost value, what's the cost value? Those are the two values inside the contract. This will be the cost value that I am asking right above here. This is where I'm asking. This is where I'm asking on the add currency function. Okay. I know it's a lot. Trust me, you're gonna get, once you do it one time and you start reviewing the smart contract, you are going to see that, oh, now I get it. So this is basically how you build that object. So then I can grab that object and call it here. So every time I add a currency, it just stores that and appends the index. You're gonna see it right here. Don't worry, don't worry. Okay, so now I need to close this right here and it should be good. Awesome. So we got that. Now here's what changes. Okay, by the way, I can remove this. I still need the base URI, of course. Now I still need to call the ERC-20, but this is how I call that struct. I call token info. Remember, that's the name of the struct, but then I want to create a storage of all the information from storage info and call this tokens. This will be the name that I'm going to call every time that I need to retrieve an information from this particular struct, which is right here. I want to store all the information from the token info in this particular object name. Okay, but then I need to make sure that this is done from the particular pool ID that the user selects. Okay. Why? Because if someone decides to mint a token, that user needs to decide which currency it's going to use to pay for it. Okay. And with that, I need to call the PID when we added the currency on the function, or when we added the currency onto the smart contract, we have to make sure that we ask the user for that. But we just mask that. We don't actually ask the user what's the PID because they're not gonna have any idea. What we are going to do, just display the token symbol, ETH, or the USDT logo or something. And when they click that, they're actually calling the PID here. It's just that they don't see that because that's Web3 coding that we are going to be doing on React.js. That's all we do, okay? So we're gonna do PID. So we're going to ask when we want to mint a token, I am going to not only ask how many tokens do you want and what's your wallet address so I can deliver the tokens, but I'm also going to ask you what's the currency? What currency do you want to use? And that is the PID. They don't see that. We just create a graphical button saying Ethereum or Matic, whichever the token you want to choose. But then we reference that to the PID when we created that particular pool ID, okay? And you're gonna see this, don't worry. Okay, so now we got this. Every time that I need to invoke something inside token info, I am just gonna call tokens. This is what I'm gonna call, okay? First, I have to also invoke the interface. And then what I'm gonna do, I'm gonna say pay token, okay? And then I'm gonna say token, check this out. This is how I'm going to start referencing this particular storage. Tokens dot pay token. And this is basically me masking this entire call and here, okay? And then I'm just need to use this, okay? What's gonna happen? Let me tell you what's gonna happen. So let's say the first token that I'm going to accept and to the R token, right? And I provided the contract address, and this will be the address of the ERC-20 token smart contract. Then I provided cost and so forth. When I call function add currency, and I provide those values, the address and the cost of each NFT, what is going to happen once this gets executed, I will receive a PID. And the first PID that we are going to receive is PID 0. So basically this particular currency is going to be attached to PID 0. Now let's say that I want to create another I want to add another cryptocurrency to the contract. I'm going to start allowing USDT, and I'm also providing the cost. When I call that function and I provide this information, then it's going to assign PID 1. You see where I'm going? Then I'm going to do the same thing once again because I decided to now accept Ethereum. I am going to provide the contract address. I am going to provide how much it's going to cost if you want to pay in Ethereum. The smart contract is going to issue PID 2. You see where I'm going? That's how it keeps adding pool IDs. It keeps adding more IDs so it can reference to the particular token. When the user, when the user decides to mint and it chooses, let's say the user chooses USDT. In the Web3 dApp, they just select USDT. We will code something that attaches USDT, the value that he touched or he selected or she selected, to PID 1. So in a nutshell, this particular value, tokens, pay token equals, basically is pay token.1 because that's the PID for USDT. You see where I'm going? So now it knows exactly which cryptocurrency is going to be calling in the transfer from, in which smart contract, so then it can do the call. That's how we reference each particular cryptocurrency, okay? So we got that. Good so far. Hang in there, we're almost there. Cost, okay? We got to do the same thing with cost because we need to tell different costs to the same smart contract. How do we do that? We say cost value, and we are going to store tokens. Remember, we are calling this the array, but then we are calling the particular PID. In order for me to get the cost of USDT, I'm going to charge 200 USDT, right? I need to call, in order for me to get this value, I need to basically call this in the smart contract. I need to call tokens cost value, which means that cost is the same value that I'm going to call here, but it's being attached to whatever cost from PID 2, which in this case is USDT, which it changes to 200. That's the amount that we are asking in that particular currency. Okay, good so far. And finally, we can go and make sure that we are calling the same functions. And by the way, we call pay token, tokens, pay token. You see? Now literally everything is attached to this. So when the end user selects the token that he wants to use, it just attached the right contract address here, and then it does the transaction as it should. Okay? The last call that we had was to pay token transfer. That allows us to receive the funds that were transferred from the buyer to the contract to our wallet. Okay, transfer me from this particular token. Okay, and we're just going to call the same thing that we did in mint, tokens PID, but then I'm going to ask when we withdraw the PID. Okay, I'm going to say PID. And we're going to call this only owner, and we're going to say token info, storage, tokens. We now can use this value to call it below. And guess what? I am going to call the same thing again. I am going to reference pay token into tokens, which is part of the storage, pay token. Why we do this? Because this is the value that I'm going to be calling in the struct. Go up, pay token. That's the one, okay? Good so far? And you know what? We're done. We're basically done. I know a lot of moving pieces, but if you want something with this type of functionality, definitely it's not going to be for the faint at heart, but it's not that hard. It's not hard. It's not hard. You just have to make sure that you're referencing and calling every time that you want to use information from here, you just have to call that storage and just create this particular value. So then you can use that to call and store what you want to store. So then you can finally call it. That's all you have to do. This looks good. We should be able to go ahead and mint. Okay, so let me go ahead and do that. I'm gonna Control C. Let's go to Remix. Create NFT. We're gonna go ahead and paste. And let's see if everything looks good. By the way, this was 1,000. Okay, cool. Go ahead and try to compile and make sure that we don't have any errors. Dun, 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 dun. Boom. Not a single error. That's cool. Next thing that I'm going to do, I am going to, by the way, you know what I should do also? I should mint the ERC-20 tokens. What I'm going to do, I am going to mint 3 different tokens. So for that, I have to, oops, I gotta go ahead and add token. Yeah, I'm just gonna make another file. And then I am going to get the staking reward token smart contract. And let me call this one right here. This should be good. And let me hit raw, select, copy. Let's go to Remix. Let's go ahead and throw it there. Okay, cool. So the first thing that I'm going to do, I'm going to create 3 ERC-20 tokens. I'm going to make 3 fake ERC-20 tokens, okay? The first one I'm going to do is the end to the rewards. And I want to make sure that I send myself, you know what? I'm going to send myself 1,000. I'm going to make 1,000. And let me make sure that I got a wallet here. Okay, cool. I do have this N2D. I'm going to use this. It should be good. So I'm going to send myself ERC-20 tokens. I'm going to first send myself and to the rewards, make sure that I'm not going to run into any errors, and I am not. I'm good to go. Inject it with 3. Now my wallet, and let me find the contract. Let me deploy the contract. Let me hit OK. Let's wait for that confirmation. Boom. Now we got into the rewards, and we should have a contract right here. Cool. Awesome. Now what I want to do, I am going to import that contract address because we want to make sure that we got the tokens that we need to buy those NFTs. And to the ER, add the custom token and import. Awesome. Let's do another contract, but this time we're going to do a fake USDT. I want to do USDT, and I'm going to send myself 10,000 to make it more interesting. Go here. I am going to recompile because we're making changes to the contract, and we are going to deploy. And now we're going to have the USDT token, not the real one. I wish. Okay, cool. So now we got the second contract. Let me go ahead and add that to my wallet. Now we got into the R. Now we are going to add a new one. Import token address USDT. Now we got 10,000 USDT. And finally, let's mint Matic. I'm just gonna do Matic and then also Matic, right? And let's recompile. Now we got token, deploy, confirm. That's the last one. And now we have 3 token smart contracts. Cool. Now we got the 3 ERC-20 tokens that we are going to use to buy NFTs. We're going to import Matic. Add custom token. Now we got 10,000 Matic, 10,000 USDTs, and 1,000 into the rewards. Now let's see that beautiful smart contract. Let me go back. Let me select NFT. Let's go here and let's deploy the collection smart contract. Let's press confirm. And we are going to see this thing in action. Boom! We got the NFT collection right here. We are starting to see some goodies. Okay, awesome. What is the first thing that we have as an option? Add currency. Do you remember that? We coded that. Yes, that is the function that we call to add a particular cryptocurrency that we want to use to charge for our NFT sales. Okay. So the first cryptocurrency that we are going to allow will be into the rewards. And you remember that was the first smart contract that we minted. I'm going to copy the address and I'm going to add that into the NFT collection. Now, how much do you want to charge per NFT if they decide to use the N2D reward tokens? Okay, so for that, we are going to charge 30 N2D rewards tokens. So we're going to type 30, but remember, this is way value, so we need to add 18 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we got 18 zeros after 30. That means it's 30 into the rewards. This is way. Now we are going to transact, and this will generate the first PID. Let's go ahead and transact. Confirm. Drum roll. Boom, we got the first PID. Let's see how that looks. So if you go down, we need to tell that allow crypto. What's the first PID? We said that was 0. Call it. Pay token. That is the ERC-20 token smart contract that we are allowing users to buy our NFTs from. Okay. Now let's add the second token. That will be the USDT token. Copy, paste. This will be the second address. Let me copy it, paste. And now how much do we want to charge in USDT? Let's charge 150. So we know this is 30, so let's just add another 0 and then add 1.5. Replace this with 1.5. That should be 150. Okay, 150 and then 18 zeros to convert this to GUI. Transact, boom. We are going to add USDT as the pay token for our NFTs. Boom, we got confirmation. And finally, we are going to add Matic. Let's copy the smart contract and let's go ahead and populate here and let's paste. And that will be Matic. Okay, so that will be the last token that we created. How much do we want to charge if they want to buy using Matic? 200. Let's change this to 20 and this will be 200. Okay, so this is 200 and then everything else is 18 zeros all the way to the right. And we're going to go ahead and transact. Now we are allowing 3 different cryptocurrencies to be used as payment for this particular NFT collection. Boom, we got the third currency. Now let's take a look. PID 1, that will be the USDT. There you go. USDT collection, USDT contract ends in FC, ends in FC. And now let's see Matic 2, PID 2, 069, 069. Awesome. And the price. So we know the cost value right here. Okay. Amazing. But we have to do one thing. Every time that we want to invoke a token that is a custom token, we need to tell the contract to approve the spender, to approve that I can use that amount to buy the NFTs. Okay, so approve spender has to be called. How do we basically tell? We want to tell the collections, and by the way, you don't have to do this with the main tokens. This is for any ERC-20 token custom that has the approve spender function. We have to do that. Okay, so what I'm going to do now, I am going to tell my N2D reward token smart contract to approve that transaction. So I'm going to say this is the collection smart contract, the NFT collection smart contract address. And I am going to tell, hey, I want you to approve X amount of value from my wallet to be used to pay. In this case, I can just go, everything. Like, I don't know, 2 million, whatever, and then just 18 zeros. And I'm going to give permission. So what you see right now is the token smart contract telling me, and this is not the NFT smart contract, this is the token smart contract telling me, hey, do you give permission to the collection smart contract to use your N2D reward tokens? Yeah, sure, confirm. So now I should be able to pay using the N2D rewards. So let's go ahead back. Now let me try to mint. Let me see what it's going to ask me. It's asking me for the PID. It's asking for the cryptocurrency that I'm going to use to buy this NFT. Okay, so what I'm going to do, I'm going to copy my wallet address because I am the one who wants to buy the NFTs, right? I want to send me those NFTs. I want to mint 2 NFTs. I'm going to buy 2 NFTs. And into the rewards, we said each NFT costs 30, right? And we want to mint 2. So that means that it's going to withdraw 60 tokens. And we have how many? Let's go back. We got 1,000. So we should now lower ourselves to 940. Okay, let's go ahead and do it. And now we're going to tell PID 0 because that's the end to the reward token. Transact. Confirm. And let's give it a shot and see it live. Let's wait for that. Wait for the confirmation, and we should see this lowering. Okay. Hey, let's go. There you go. We bought 2 NFTs using the N2VR staking token. But this is not the end of the party. We need to buy using USDT and Matic. So what I'm going to do now, I am going to change and I'm going to buy using USDT. How much did we charge the contract using USDT? And we can check. Let's see. USDT is number 1. So we're charging 150 USDT per NFT minted. So if we select 2, it's going to be 300. You know what? Let's select 3. So we change the value. So we know it's different now. So it's going to be 450 USDT. Okay. And we're going to use USDT. That's PID 1. And we're going to mint to my wallet, which ends in 55. Okay. Let's go ahead and transact. And let's wait for that. 450. So we should lower ourselves to 9,560 and 50. 550. 9,550. Wait. Awesome. Awesome. There you go. We bought using N2R, the reward tokens, our staking tokens. Now we bought NFTs from the same collection using USDT. Now we are going to buy using Matic. And the only thing I have to do now is change this PID to be 2. That's Matic. Okay. And we're going to mint 3. Let's mint 3. Let's go ahead. Let's give it a shot. And that's our last currency. So we bought. And there you go. Awesome. 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 So we bought NFTs from the same collection using 3 different cryptocurrencies. That's how we do it, man. That's how we do it here. That's how we definitely do it here. Put this to practice and give it a go ahead. This is awesome. This is amazing. Let's continue the show. All right, so that's it for this video. If you like my video, you know what you need to do. Please give it a thumbs up. Subscribe if you haven't subscribed to. And we'll see you on the next video. Bye.